Good afternoon. Today I will be presenting planar solid phase microextraction ion mobility spectrometry, and I will be performing a demonstration of this technology. First of all, the trace explosive detector that we will be using for the demonstration is the mobile trace by morpho detection. And prior to conducting any experiments for the day, the protocol is to always perform a calibration and a verification at least once daily. So first of all, we will obtain our calibration traps. And you can tell the difference between these traps by the letter that's on them. So this is C for calibration. So we go to the instrument screen and select Cal, which stands for calibrate. Now the instrument is requesting that I insert the cal trap and press trigger. I am pressing trigger on the screen, and the instrument is sampling. The sample takes about 8 seconds. So the instrument has calibrated itself, and it provides you with a data file number. And I just press OK. And I don't have any notes, but it is an option. Press Enter. And the screen tells me that the negative calibrant has been calibrated to a certain position, and so has a positive calibrant. So this means that the instrument has now been set and calibrated. And we see that it's telling us that contraband has been detected. So these calibration traps contain TNT and cocaine, and we see 2 peaks for these. TNT in the negative mode and cocaine in the positive mode. So we remove the calibration trap and discard. Now that the instrument has detected these compounds, we normally do a clear function in order to help clear out the analyte that was detected. So on the touch screen, we press clear. Now the instrument requests that I insert a clean trap. So you take a trap from the sample traps multi-purpose canister. And this trap has no letter on it. It's just a hole. So I insert the trap into the desorber and press trigger. And we see a green screen, and it says that there is no alarm and the instrument is ready. So we discard this trap. And now we're ready to perform a verification. So you select a verification trap from the canister labeled multi-purpose verification traps. And these traps have a V on them. So prior to inserting the verification trap, I need to go into the menu and select Verify on the touch screen. And now the instrument requests that I insert a verification trap and press trigger. Okay. The instrument indicates that verification is successful. And again, these verification traps contain 2 additional compounds in order to verify their drift time position. So now that we have a hit, we'll press clear. And now again, the instrument is requesting that I insert a clean trap. And again, I will take one from the sample trap canister. Press trigger. Okay. So no alarm, ready is what comes up in a green screen, and that means that we are ready to analyze our samples for the day. So today we will be showing you how to conduct peace-BME sampling and couple that with ion mobility spectrometry. So we will prepare a can to create a closed environment, completely sealed, for us to conduct static sampling with the PSPME device. So our setup is as follows. We have a baked quart-sized can. We use a binder clip to attach the planar solid phase microextraction device to it. And we're using unwaxed, unflavored floss. And we are attaching this to the can with scientific tape. Okay. So the solution that we will be extracting from is a spike of 240 ppm TNT in acetonitrile. I will take 10 microliters of this solution, and this corresponds to a total mass deposited into the can of 2.4 micrograms. But prior to that, we have to ensure that our planar solid phase microextraction device is blank and ready to accept our sample. So this is a planar solid phase microextraction device, and I will insert it into the instrument's desorber and press trigger. I obtain a green screen, and it says that there's no alarm and the instrument is ready. So the instrument provides you with a file name, and you can record that. Just press OK. I don't have any notes to enter, so you press OK. So now that I know that my PSPME device is blank, I can introduce it into the can. But I will set it aside for now. Actually, no. I will remove the lid from the can and set up the PSPME device within. So I attach the PSPME device to the binder clip with the binder clip. And the device is suspended into the can, the headspace of the can. So I will take 10 microliters of this solution and deposit it into the quart can. Now the can will be sealed with this hammer. And extraction will be performed for 15 minutes. So during this 15-minute time span, the PSPME device is allowed to come into contact with the headspace of the TNT that we deposited. Again, it is important to remember that we deposited a very minute amount of TNT into this can, and this device will be used to absorb the vapors that are emitted. And following the 15-minute extraction period, we will introduce the PSPME device directly into the instrument, and we will obtain an alert for TNT. Okay, so we will discard this. Now, we also want to ensure that the vessels that we're performing these extractions in are blank. So we have a baked can that contains no analyte inside. Okay. So we will sample this blank can just to determine that there is no extraneous compounds that we are detecting by ion mobility spectrometry. But again, whenever we perform extraction with PSPME, we have to ensure that we first obtain a blank with the IMS. So again, we're going to insert the trap, or the PSPME device, into the desorber of the instrument, and we will press trigger. Okay. There is no alarm, so we are ready to go. So I've removed the PSPME device from the desorber. And now I will introduce it into our air sampler, as so. our Peace Beamy device is in place, and I will sample this can for 30 seconds dynamically. Now that we have performed this dynamic extraction with the planar solid phase microextraction device, we'll remove it from the air sampler and place it into the instrument's desorber. And again, we press trigger. And now the instrument is sampling. Okay. So we obtain, again, the green screen, and there's no alarm, and the instrument is ready to go, meaning that there were no compounds in the blank can that were extracted or detected by the ion mobility spectrometer. Our next sample is a smokeless powder, a small amount, only 100 milligrams, and this has been sealed inside the can since 7 this morning. So it's been sealed for about 6 hours. But prior to performing this extraction, again, we need to ensure that our Peace Beamy device is blank, as indicated by our instrument response. So again, we take our device, introduce it into the instrument's desorber, and press trigger. We have no alarm, so we can proceed with sampling and extraction. Again, I'll place the Peace Beamy device into the air sampler. I'll set my timer for 30-second extraction. Okay. Now I will open the can up. Now that our dynamic extraction is over, I will introduce it into the desorber and press trigger. Okay. So we see that explosives are detected from this small sample in as little as 30 seconds of extraction. So the instrument provides us with an alarm data file, and it's ALM01131. So we just hit OK. Again, I don't have any notes to enter. And the instrument informs us that DNT has been detected with a drift time of 5.608 seconds. So in as little as 30 seconds from a very small quantity of the smokeless powder H322, we were able to extract sufficient quantity to produce an alarm by IMS. So the whole process took under 40 seconds. It is important to note that these pre-concentration devices have very large capacity. So even though we have performed one desorption, we still may have some compounds remaining. So in order to check for this, we will desorb the device again. Again, I introduce it into the desorber and press trigger. Again, there are still more explosives that are coming off of this device. And this shows how much was, in fact, extracted by the PSPME device, again, in as little as 30 seconds. So again, I will desorb it one more time. And again, we are detecting explosives. Okay, now that we have desorbed the PSPME devices a few times, because it did collect much of our analytes, we're going to remove it from the system, and the IMS says that there's no alarm and it's ready to go. Now, the reason that you would want to desorb it several times is because, in fact, these devices are reusable. So if you wanted to move on to another sample and you had extracted a large amount of your analyte, you would want to clear it out and certify that you do not have any analyte remaining on your PSPME device prior to moving on to collecting another sample. So now our spike of TNT within a can the PSPME device has been in contact with the headspace produced from this very tiny amount of TNT that is within this can. So because TNT is semi-volatile, there are vapors available to be extracted by the PSPME device. So once your extraction period is over, you open the paint can as so. Okay. Your tweezers. You remove the device from the binder clips. Introduce it into the desorber. And press trigger. Okay. And as expected, we have absorbed TNT on this device, and we obtain an alarm. And we obtain TNT at a drift time of 6.076 milliseconds. And as is usual, you would want to desorb this device again to ensure that it is blank. Okay. And again, we hit on TNT once more. Now we're cleaning out the system, so it's requesting me to insert a clean trap. Okay, no alarm, and we're ready to go. So now we have already spiked within a can and sampled statically. We have dynamically sampled a blank can, and we have also dynamically sampled a very small amount of smokeless powder within a can. So our last demonstration is going to be with the smokeless powder red dot, and we will perform a static extraction for only 5 minutes. And we will be sampling from the headspace of 100 milligrams of sample. But before we present the PSPME into the extraction, or into the vessel, we have to ensure that it is blank. So place it into the desorber and press trigger. And the instrument is green, provides a green screen, and it says that there's no alarm and we're ready to go. So this small amount of red dot smokeless powder has been sealed within this can. So I will open it up, simply to introduce the Peace Be Me device within. We seal the can with the mallet. And we have our timer set for 5 minutes. So in 5 minutes, we will remove the extraction device and introduce it again into the desorber and press trigger. Okay. So our 5-minute extraction period is up. We will open the can, which contains 100 milligrams of red dot. Remove the Peace Be Me device from the binder clip and introduce it into the desorber. And I press trigger. Okay. And we detect explosives. The red screen comes up on the instrument, and we detect the compound nitro. So again, we're going to desorb the Peace Be Me device again. Press trigger. Okay. And again, explosives were detected. This is evidence that the Peace Be Me device collected a large amount of this nitro compound from a short 5-minute extraction from a small amount of smokeless powders. We're going to clear the instrument. I'm inserting a clean trap, pressing trigger. Okay, there's no alarm and we're ready to go.